So my name is Jenny Wilson-Welder. I'm from the National Animal Disease Center, part of the Agricultural Research Service, part of the USDA, located in Ames, Iowa. So I'm not going to read you my full pedigree here. As I was preparing this slide from another presentation I brought over, one of the things that really struck me was how many times the word vaccine jumped out in all of this. I've been studying vaccines for almost 20 years, and that's just been my bread and butter. And not just vaccines, but how do we apply vaccines to different situations? How do we use adjuvants to manipulate the immune system to get the response that we want? So all of that led me to my work here, National Animal Disease Center. That's on the north side of Ames. You may recognize some of these buildings. This is I-35 as it moves along. On the right side of the picture there are big buildings. Some of our containment buildings. Our buffalo are out there on the far side. You'll probably see them as you drive north out of town. We're part of 3 different centers that are located at that facility. One is run by ARS. The other 2 are run by APHIS, including the National Veterinary Service Laboratories and the Center for Veterinary Biologics. So if you want to know a little bit more about us and what we do, there's a really great website listed there. So what makes Agricultural Research Service different? What sets me apart from my academic colleagues? We tackle big problems, big goals, and with that we're allowed to take some pretty big risks. Things that don't always fit so nicely into a student's dissertation. Things that take, like prion diseases, take 10 years to even develop in an animal. So we have a little bit more consistency. We work on a 5-year funding plan. We have a little bit long-range planning. Sometimes I say our progress is measured in rolling that boulder up the mountain in inches, not necessarily in feet. Another thing is, everyone says they're publish or perish. We really are. We've got to find a way to publish that. We're very highly encouraged to pass any technology we have on. A lot of times this is in the form of publications, but it can also be in CRADAs and licensure. And we're one of a few centers in the world that are entirely dedicated to livestock. And most of those centers around the globe are dedicated to diagnostics. We're one of the few that are dedicated to research of animal disease and basic research at that. So I wasn't hired as a microbiologist. I was hired to work on leptospirosis and digital dermatitis. So some people think that we're a little bit put into a box, that our work is really kind of constrained. But what we do inside those boxes, we're given a lot of freedom as to how we approach our problems. So that being said, I think we're pretty good collaborators. Our budget's very modest compared to the rest of the government. We're pretty good bang for the taxpayer's buck. Other thing that sets us apart from our academic collaborators is we're small. Most people are a scientist and they're a technician, but yet we seem to get a lot accomplished. Spirochete diseases, we're 2 scientists, 2.5 scientists, 2 technicians, and a postdoc, and we cover 2 pretty broad diseases. I would like to say that leptospirosis, we're the probably premier laboratory in the world working on that as far as cattle and livestock are concerned. And digital dermatitis, we're the only ones working on actually the immune response of digital dermatitis at this time. Both of these diseases being so small, we either know everybody or are already working with them around the globe. For those that aren't as familiar, leptospirosis is one of the most increasing zoonoses in the entire world. It's the most neglected tropical disease you've never even heard of. It affects people and animals of all range. Most mammals are susceptible. There's even been some evidence that reptiles can carry this pathogen. It's definitely a pathogen of climate change, infrastructure breakdown, human-animal transboundary disease. All of this is really highlighted right now in the outbreak that we're seeing in Puerto Rico, where hurricanes caused excess of rain, flooding, breakdown in infrastructure. The other high risk factor for leptospirosis is agriculture. You can see here the flooded rice paddies, but the reason we have a cattle vaccine for leptospirosis is because New Zealand dairy wives actually lobbied to get one made to protect their husbands and the other workers in the dairy industry. Leptospirosis isn't an easy problem to solve. There's over 200 serovars spread across 9 species. It's endemic in most wildlife in an asymptomatic state. Cattle, it does cause some disease. It's mostly asymptomatic, but you'll get some late-term abortions, stillbirths, weak calves. It's one of the leading causes of reproductive failure in cattle. It's probably underdiagnosed in the US and around the world because in livestock, it's not necessarily a reported disease. And so while we may think of my little poster child up there holding her pet rat, the biggest risks actually come from a myriad of different places, including dogs, pigs, and cattle. So just like with rabies, if we can vaccinate the transmissible host, we can actually protect humans from a zoonotic disease. So there are many different bovine leptospirosis vaccines out there. We've been studying leptospirosis and had leptospirosis vaccines since 1960s. There's some that are 5-valent or contain 5 serovars in them. There's some that only contain 1 and have been well studied and for the most part work reasonably well. And then leptospirosis is part of what I refer to as the kitchen sink vaccines. They have not just leptospirosis, but clostridial, respiratory, and some viral diseases in them as well. This by no means is an exhaustive list or anything. But as far as the leptospira component goes in all of these vaccines, they have something in common. They're all whole cell bacterins with an alum adjuvant. And so that really kind of, when I started working on this, I had 2 big questions. We've been working on the lepto for a long time, but what type of immune response is associated with the protective vaccine? Is it Th1s, Th2s, NK, is it antibodies, the cellular response? We know that invoking the wrong immune response by altering a vaccine, best case scenario, you get vaccine failure and persistent infection of that animal. Worst case scenario, you get immune-mediated pathology. And when we're talking about an organism that lives in immune-privileged sites like the kidney, immune pathology now is damaging the kidney, and that's not good for anybody or anything. The second question I have is, okay, if we understand that, how can we change or improve upon the immune response by the use of adjuvants? Right now we're using bacterins, and they contain lots of different things in there to stimulate the immune system. But like I said, there were 200 serovars, and so we can only protect against those serovars that we have in that vaccine. As we move towards the holy grail of vaccines, so to speak, in finding universal antigens that will protect against all of these, we're going to remove some of those PAMPs from those vaccines. We need to find something that will help protect against all of them, and we need something that's going to whack the immune response and make it pay attention. So what I'm doing isn't anything novel or new. I'm just finding other people's wheels and putting them on my cart. But do we need the old tried and true, the alum that'll give us lots of antibody? Do we need something fast and light to induce a quick immune response in light of an outbreak? Or do we need the all-terrain tire with the spinning wheels and the whole works? So to answer question 1, I'm proud to say that we finally got this paper out this year. It was a long time coming and a lot of work went into it, and you're more than welcome to go look it up, but we did find sort of what we think is the core immune response to leptospirosis infection. Cliff Notes version, it was a relatively easy vaccine design. Immunize cattle, measure the immune response. Infect them, measure the immune response. We used 2 efficacious vaccines, Leptospira and Leptovoid. And again, the 30-second summary, memory response, the protective response seems to be associated with memory CD4 cells, WC1 gamma delta cells shortly after infection, probably playing a role in somehow helping clear the bacteria. We get IL-17 and interferon gamma from antigen-stimulated cells, indicating a very pro-inflammatory response in both IgG1 and IgG2 antibody. So that brought me to the second question, to improve the immune response by adjuvants and different vaccine delivery vehicles. And so here we had a really great opportunity to partner with our local universities and some of their vaccine development groups and sort of take their pick of the litter in what was some of their promising platforms. And we were able to choose materials that, for me, I thought had really great properties and things that really were going to be value added in the livestock industry. The polyanhydride compressed time-release rod capsule from Iowa State, it had the advantage that it was a single dose. Now, a single dose doesn't seem like that big a deal until you start thinking about livestock. It costs a lot of money to round up animals in labor. It takes nearly a day for feedlot steers to settle back down after being put through the chute to start gaining weight again. So now multiply that over and over and over, and you're talking about considerable savings to a producer if you can do something in a single shot. The diaminosulfide particles from University of Iowa and Dr. Salem's group, both of these I think are being presented in further detail by others in this conference. These, I liked them because they were shelf stable in their dry form. So now we're taking the cold chain out of the supply. They were made from cheap, easily manufactured materials, and they were soluble in water. So pen side, inject, flick, flick, off you go. I was really excited about these materials. And then we used Cepic Monotide's ISA 201 VG mineral oil emulsion because we had literature that suggested that this would enhance a Th1 type or cellular immune response. We compared these to the tried and true Spirovac, and then because we were using dried antigen, a little bit different antigen preparation, we wanted to put that into the tried and true classic aluminum hydroxide. That is a picture of Knickers up there. He's the world's biggest cow or something from Australia. Holstein steers, if you keep feeding them, they really will get that big. We had the opportunity to use some Holstein steers. They were almost that big. That was just one of the reasons why we didn't do a challenge in this study. They just weren't going to fit in our containment. Two, boys are messy, and leptospirosis is a urinary disease. So we just did a vaccination study on these. The materials that we used were patented. They're covered under patents, each of them. The one is waiting examination. It's co-owned by University of Iowa and USDA. The others are all held by Iowa State University, and then the monotide is available from Cepic, and I think it's already in use in several different animal vaccines. Again, these results are published. We got a little shout out on the cover of Biomacromolecules. Emed and I were very excited about that one. And a little bit more detail about the immune response and the other polymers in Journal Vaccine. This article is also available as open access. So again, kind of the Cliff Notes version of these two studies. As far as antibody, we've got agglutinating titer from all of our different vaccine constructs as early as 8 weeks. The magnitude of the titer was a little bit higher at 8 weeks in some of our vaccine constructs, especially the sulfonamide microparticles and the Cepic vaccine, but on all it was equivalent or on par with Spirovac, our efficacious commercial vaccine. And when we took and broke this down into an antibody-specific ELISA, we did get IgG1 and IgG2 antibody isotypes. Cellular response, again, very much like our efficacious Spirovac, in that we are seeing a CD4 response. These cells also had a memory phenotype. What I'd like to draw your attention to is the Cepic adjuvant at this point, and that we saw this higher magnitude response at 4 weeks post-vaccination. So at this point, they'd only received the initial dose, not quite the booster, and yet we're getting this really great initial response. So this is something that I would definitely consider using in light of an outbreak or something, because I think we were getting a little bit earlier of an immune response. And again, looking at those inflammatory cytokines, at 20 weeks post-vaccination, they were on par or equivalent to our Spirovac, our efficacious vaccine. So looking at novel adjuvants and delivery platforms, the Cepic Monotide, our oil water adjuvant, equal or superior performance, maybe even a little bit earlier or higher magnitude of responses. The polyanhydride or V-Pure rod, while those responses didn't seem to be stellar, they really were there, and I think that they were sufficient, especially after a challenge boost, which I didn't have time to show you all the data. And again, that was a single dose implant. So I think there was still a lot of value to be had from that particular vaccine platform. The diaminosulfide particles, equal in performance to BioVac, shelf-stable in a dry form, easily manufactured. And this one really, it had less tissue reactivity than the Septic oil, water, and adjuvants. And while you think, oh, you don't want that tissue reactivity in people, in animals it's even worse, because now that carcass with that little bit of granuloma is condemned, and you've lost all profit from that animal. So we were asked to specify what we might be looking for the spirochete research group, and I think I'm speaking for pretty much all of everybody out at NADC when I say this. We're very open to collaborations with universities and companies. We have mechanisms for doing this. There's a lot of forums, and we have to make sure all the I's are dotted and T's are crossed, and these take a little bit of time. Right now we're undergoing some leadership changes from the top to the local levels, and that adds considerable time. But for the leptospirosis group, we've got bovine models for leptospirosis and immunology, sheep models where we have the immunology tools there available to us, as well as a rat model of leptospirosis. But we've got some caveats. We have limited money. Anything that we want to do above and beyond our project plan, it's got to account for this. Like I said, one scientist, one technician, that's it. So we have to have means to overcome that, and that's with that package deal. And challenge and containment space is limited. We got beautiful facilities, really great. And for the most part, we can house a cow or a sheep, out in the pasture and feed them for about what most academics can feed a box of mice. But it's the challenge phase things get really kind of tricky, and we must be able to publish the results. Sometimes it takes us a little while, but we get it all done. As with anybody, nobody works in a vacuum. Lots of hands contributed to this work. And so shout out to all of them and the collaborators at our university. There's my email if anybody has any specific questions. I know just enough about the polymers and the mechanics of those to be dangerous, but the immune response is all mine. All right, thank you for listening.